Okay, so I've been racking my brain over this, and the idea is that you have a coordinate pair of all of these points where you can say that you can trap the map if you would. And what happens is that if you have a linear function that is traversing the x and y axis, because if it's just 2D, what we can say is that the bingo hall of all of the placeholders, for instance, like in the previous video, we had Hyphy, Tika, and those happened to fall on a significant plane. So we're on a function. So at Hyphy we're on function, at Tika we're on function. But what about somewhere falling off of the linear path? Or if it's nonlinear, then it's just not part of the function. So we see that high times, for instance, because I don't know what it might be otherwise. High times falls a little bit off of the function and is able to be triangulated in between Hyphy and Tika. So in this bingo hall of placeholders, we're on the same longitudinal line. So we're essentially on the same longitudinal line. However, we're not on the linear path. We're not on the function. So what we're doing is triangulating in between high times, Hyphy, and Tika to find out what is the least distance in between these 3 points that could keep us at a remainder on closest to the function. So that's what we're doing constantly by trapping in what could be a nonlinear function, what could be a three-dimensional function, which would most likely is when you're in the air, and when you're in real life, and other than being smack dab discretely on the street. So what happens is we're getting a midpoint closer and closer to being on the function line itself. So this equation could be f of n equals x squared if it's exponential, let's say. So if it is, our expectations are the further that we traverse out, if it's an airplane or if it's some kind of rocket ship or whatever, the higher we're going to get and the closer we're going to get to the moon or the stars if it's exponential. If it's linear, f of n equals 2x, let's say, we're doing a step 2 function. So every for the equation, every 2 steps up is 1 step forward. So we go 1 step forward and 2 steps up, 1 step forward and 2 steps up. So that's f of n equals 2x. In this case, it's a lot easier to stay on the part of the function. This is important because when you're trapping live, your ability to really connect the dots is profound when you know what you're doing. And if you don't know what you're doing, if you don't know what the function is, if it is this complicated, if you're in the air, and if you're not discretely on the street, it can be a lot harder. So the idea is that all these placeholders become a little bit less of a bingo hall and more of a way to intermediate in between the 2 points. And so we're finding midpoints. And if you're familiar with linear algebra, you'll notice that it can come down to least squares regression. So it's like it's a way of regressing the the actual function by just simply outputting different triangulating different points to test the all the points that we have mapped out already. So that's one thing that I'm gathering. I'm not an expert at trapping, but the thing is that if you're trapping live, that you're really able to get into a three-dimensional space by doing this, and it becomes profoundly accurate if it is linear. So if you have, let's say you have somebody that's flying a kite or somebody that's in a hot air balloon, and they can see the grid, for instance, they can see the crops and the grids and stuff in the city map. So they can say like, okay, so I can see the Sears Tower from above, like, okay, so that's going to be Oldie or something. I don't know. And I can see J-Dub Marriott. So that's going to be J-Dub, whatever. And so like you see that this hot air balloon is taking on it could be taking on a very linear path. And so the ability to trap live for the hot air balloon is a lot more accurate than, let's say, a rocket ship, that's going on an exponential function or who knows what it is. So that's what I got to say about that. And the other thing is that you can inverse the axes because we are coming at different directions, and everybody is on this Cartesian map, if you would, in their cars, let's say. They're coming from different directions. So it's not like they're pointing outwards on the x-axis, going right on the x-axis, and going up on the y-axis. So it's not like they're lockstep with having to go certain directions. They're coming from different directions. So we can have inverse functions. We can have the hyphy Antica be Kit, Tiger, and fire hydrant. I don't know. I don't know why that's funny. So anyways, so that's the point. It's just that you can have, you can come at it with different directions, and you would be having to triangulate in different ways. So thanks for trapping, and stay live and on air. And I will just end this stream right now.